Hello and welcome back to this course of videos on MongoDB. In this video we'll be continuing to post our data from our registration page using Ajax to our PHP server and then populating it into the MySQL and Mongo databases. So we'll look at the MySQL submit into the MySQL database first. Now, for both MySQL and Mongo, the first thing we need to do is to get the maximum ID because we need to populate our primary key field. If we look at our MySQL database, we can see this ID field is our primary key. I chose not to do an auto increment field as I wanted more control. So before we insert a record, we need to find out what the maximum ID is in the primary key, so we can add 1 to that, and then so to make sure that the record is unique. So what I'm doing is, first of all, we're running this line of code here. So we're taking our connection object, which we saw from our db.connect here. This is our connection object. And then we're running this query method. Again, here is the PHP version of dot notation, but this query is a method on the connection object, and then we pass in our SQL, which is select maximum ID from the customers table here. Now, we then, from taking this query object here, we run the fetch column. Now what fetch column does is it can take a parameter which is the actual column that you want to fetch data from. So I don't need to specify a column because we only have one column, and this will basically pull the first row and the first column. If I repeated this code, if I repeated this line of code, it would pull the second row. This is going to bring me back my max ID into this variable here, and then I'm just adding 1. So this is going to return me, if you look at the MySQL table, it will return me a value of 13. Now we move on to inserting into this table. Now this is where we move on to a key difference between MySQL and Mongo. If you remember to earlier videos, working with SQL databases, we normalize them. And the way we've achieved that here with our customers database is we split the customers and the customer emails across 2 tables. This is, as we mentioned before, because certain customers have more than one email address, like customer 1 has 2 email addresses. If we put them on this table, we'd be causing a lot of redundancy, and it wouldn't be normalized. So normalized is the word that we use for making sure there isn't a lot of redundancy in the table. So, but in Mongo, it would only be 1 table, because using embedded objects, we can achieve an optimum data model without having to create separate tables, separate collections. But in here that's not the case. So because of that, we've had to use something called transactions. So you can see the transaction begins here and it ends here with the commit statement. If it fails, we do a rollback. Now that is because we only want to commit this transaction if both tables are updated. If you look on we have these fields here are from the customers table, and these 2 fields are from the email table. We don't want one table updated and another one not updated. So that's why we need to use this transaction. So we begin the transaction, we provide the SQL string for inserting into the customers table. This is the customers table here, no emails. And then for inserting into the emails table is a separate SQL string here, SQL2. If you look, I just have an if statement depending on whether both email fields were filled out or only one was filled out. I have to do an if statement. If only one email field is filled out, I'm just adding one row to the customer emails table. And if there is more than one, basically if email number 2 isn't null, so basically if this isn't null, then I'm going to run my code and add 2 separate rows to my email table. So we then, once we've populated our SQL strings, we then do a try-catch statement and we execute both. Now if both have executed successfully and we haven't moved into the catch statement, then I commit and I echo back my congratulations to the user. If there's any kind of exception with either of the 2 inserts, then I'm going to catch it and I'm going to roll back. So that means neither of these 2 tables would have been populated, which is what we want, because at least then we have consistency and our database fits in with the ACID compliance that we look for with relational databases. And of course I would also communicate back to the user there was an issue, and then I'm going to stop the program. So that is the SQL code. Mongo code we will walk through now. So first of all, we want to specify the actual collection that we want to work with. I mean, if you look on the MySQL side, we specify the table name in every SQL statement. However, in Mongo, it doesn't work that way. We specify the collection we want to work with up front by using this. We're taking our DB object again. The DB object is what we specified in when we first connected, so that's our DB object. With this DB object, we then specify that it's our customers collection that we want to work with. If we switch over quickly to Mongo, RoboMongo, you can see this is our customers collection here with our 12. It's probably easier if we look in table view here with our 12 documents added to our collection. So the next thing we're going to do, similar to what we did with MySQL, is we have to find the biggest value, the maximum value in our, this is our primary key field here, _ID. Again, I decided to do mine manually to have more control rather than letting MongoDB provide the primary key for me. So we need to find the maximum one. So in order to do this, we will be using the find method against our collection object here, using the single arrow notation instead of dot notation. Now, the way that we're configuring this statement here is quite different to the native Mongo code that we're using in earlier videos. What we basically want to do here is we're not filtering for any rows, but we do want to only return the ID field, so that's our projection. We're sorting descending and we're limiting by 1. Now if we look at the same code in Mongo, it's extremely different. It's a find method still, but if you compare the two, first of all, the fact that we're not filtering using any filter criteria for rows, you can see this is a JavaScript object, but on using the PHP library and driver, it's an array. So that's kind of the first difference there. And then a second big difference is if you look on the MongoDB side, these two JavaScript objects here separated by the comma within the first set of parentheses, this covers our row filter criteria and our projection. So we're projecting and saying we only want to return the ID field. However, on this side, it's completely separate. Our first argument is the row criteria, which represents this JavaScript object here, but our projection is actually part of a second array. So we have the first array, which is our row filter criteria, and a second array which holds all of the other arguments, including one for projection. So we're saying projection, and then the arrow, and then saying the then a sub array for the, just to show it's the ID field that we want to project. So very different to the native Mongo side. And again, looking at the sort in this on the PHP using the PHP driver and library, as I said, all of the other arguments outside of the row criteria, the row filter criteria, are in the second array, including sort. You see, I have sort, I have limit, and I have projection, all within this second array. However, on the native Mongo side, we were using chaining. You can see we've got dot sort, and then we pass it as a parameter this JavaScript object with an ID of -1, and then the same thing for limit. Limit is also chained. You see, it's chained with this dot notation. However, on the PHP Mongo side, again, it's another argument that's passed in this second array that is passed through, containing all of the other arguments. So this is quite a big difference between the syntax of the two. Now all I'm doing here, now I have my document list, which actually only obviously contains one document because we're only returning one particular ID. But regardless, I just did a for each, so I can grab the first document, first and only document, and then I'm going to, into this new PK, I populate that result, which is 12, and add 1, which is going to give me 13 in here. And then I can use that to insert into my new collection with the rest of data. And we'll actually leave that, we've hit the 10-minute mark, so we're going to leave inserting into the Mongo database to the next video, and I look forward to seeing you then.